This is a Shiny for Python application. It's a UI written in full Python with a FastAPI backend in this architecture. I'm going to type in a short sentence here. I'll press the Analyze button, which is a Shiny button. It connects to the FastAPI server over HTTP, returns a processed portion of the text where it does some basic analysis, the length and the number of the words. This is also a Shiny button here, which does a health check to the server on the endpoint, API endpoint / health, and it returns OK. This is the basic architecture. We have a web browser, which is the client. We have a Shiny application, which is hosted on the free tier of Posit Connect Cloud. It goes back to the client. The Shiny application sends HTTP at endpoint analyze with a JSON body over to the FastAPI server, which is running on a separate Python server. The Python server gives a response back here, gives it to the Shiny app, and eventually gets to the browser. The FastAPI server is simple. It just has 3 endpoints for educational purposes: /health, /chi, health check, and then /analyze, which does some basic processing on the text. We are using this architecture because in the future, we want to extend our FastAPI server to connect to static assets with S3 on the Shiny application on the Posit Connect Cloud. You can't store these static assets. So we're going to connect it to FastAPI and store the static assets over on a S3 or S3-like server. Also, we'll connect it to a PostgreSQL database, and you can store the data from things like spreadsheets into the PostgreSQL. We're going to parse the spreadsheets or CSV with FastAPI and get it into the database. And we'll also use an AI to connect it to either Ollama or OpenAI. If you follow this simple architecture, the client, the Shiny, and the FastAPI, it gives you more flexibility in the future for common things that you can do in Python backend, such as connect to a database, connect to an AI, or connect to a storage system such as S3. The entirety of the FastAPI server is 30 lines. It's all in one file. The main thing is this endpoint analyze. When it returns it, it does some simple things to the text, including, so this is a string, right? Including text.upper, the length of the string. It splits it on the word or the space, and it does a word count. The Shiny application also written in Python. We have the output that goes to the screen right here. And it does a endpoint. So it's using HTTPX with the asynchronous client. And then with the data, we can now take the individual pieces from the server response and have it be on the web page response. The UI of the screen is also written in Python. So this is one component, and I'm calling it main app UI. And it uses this convention, for example, UI.h2, and there's a piece of text here. So this is obviously the HTML h2. This would be the HTML hr, right? And so this is input text area. These are other components that I have. I'm using a model view server architecture, and within here is the screens, and these components are, for example, the health check component, which is more UI code. In future videos, we'll cover these steps one at a time. Main primary concept is that there are 2 servers. They're both in Python. One is the UI server, which is built in Shiny. It's hosted on the free tier Posit Cloud Connect. And the second server is written in FastAPI, and I actually have it hosted on the free tier of Leapzip. So in the Shiny application, I did divide the application into separate folders. There is a server folder for the server code and a view folder for the UI components. Within the view folder, there are 3 separate folders: authorization, auth, screens, and components, and each of these have separate files in it. There's also an app.py entry and a config.py. My initial evaluation, it appears that Shiny can be architected into a fairly normal Python architecture type of application, and it can also connect to the backend FastAPI server. So in the next video, we'll start going through the Shiny code line by line so that you can build it yourself.